This tutorial deals with the georeferencing of raster data. Georeferencing is the process of assigning real-world coordinates to each pixel of the raster. Many times these coordinates are obtained by doing field surveys, collecting coordinates with a GPS device for few easily identifiable features in the image or map. In this exercise, we will use the boundary of map image as control points and connect it to the municipal boundary shapefile data. Control points are locations that can be accurately identified on the raster dataset and in real-world coordinates. Many different types of features can be used as identifiable locations, such as road or stream intersections, the mouth of a stream, rock outcrops, the end of a jetty of land, the corner of an established field, street corners, or the intersection of two hedgerows. Our data is saved on a folder, the raster and the shapefile. Now, let us add the shapefile and raster data in the data frame. Remove the fill color of the polygon to make it transparent and visible. We will use the georeferencing tool of ArcMap. If the georeferencing tool was hidden, just right-click in the upper corner of the window, then mark Georeferencing. In the georeferencing tool, select your target raster data previously added to the layer. And then, click the Fit to Display to overlay it with the boundary shapefile. The JPEG file will be automatically shown on the data frame, then we can see now the possible control points on the raster data. As I said that in this exercise we will use the municipal boundaries as control points, therefore, find for the boundaries on the JPEG file with the same position on the shapefile, then connect it. I will use the edge of the Isabella boundary from the JPEG file as control point, then, connect it to the shapefile. Generate at least 4 control points. If you think you already precisely generated the control points, then rectify the georeferencing. ArcMap will not automatically show the output on the data frame. Instead, you need to find and locate it according to the output location set during the rectifying. Right-click the folder where you saved the output, then refresh it. The TIFF file will be added on the folder, then that's it. After adding the TIFF file to the data frame, then remove the old data on the layer, which is the JPEG. Take note that in georeferencing, we can use the specific locations such as the X and Y coordinates of any feature or landmark as control points which are visible in the image. The JPEG was processed and converted as TIFF file, and now, we can further process the data. In this exercise, our objective is to extract the area affected by the flooding in selected municipalities of the province of Isabela. Out of the 38 polygons or municipalities in the vector data set, we only need the 4 municipalities such as San Pablo, Cabagan, Santa Maria, and Santo Tomas. Let us review the JPEG file of the flood map to see what are the symbols used. We can see that the red symbolizes the flood extent while blue symbolized the inland water. This time we will perform digitizing to manually extract the flood extent as well as the inland water. We will also use the editor tool of ArcMap for the digitizing, but first let us create a polygon in the catalog its specific folder. Now add the draft polygon to the layer, and then activate the editor. Remove the fill color of the polygon for easy visualization. Take note that we still have a blank shapefile. Upon activating the Editor tab with Set of Tools will automatically reflect on the window. The cursor of the mouse will also automatically change into a triangle. And then open the Create Features through the Editing Features of the Editor tab. The Create Feature window will be displayed on the window, and then select the blank polygon, then select appropriate geometry on the lower portion of the Create Feature window. Now proceed to digitizing. Using the editor tools, trace the flood extent and inland water within the target areas. The first polygon, which is the flood extent, was already traced. Again, let us review the JPEG file of the flood extent map, then check for the next feature to trace or digitize. As we can see the need to separately trace the inland waters, these are the features on the image with blue symbol. This time, generate another polygon for the inland waters in the same folder. Again, digitize the inland waters using the editor tool. This time, we will use the trace option in the editor tool because our target feature is just on the edge of the existing polygon, which is the flood. Just trace and follow the polygon of the flood to make the task easier. Don't forget to always save your edits in the editor tool, because the editor tool will not automatically save the edits. Now let us generate another polygon to clip hollow areas in the features. This is done to polygons with hollow areas at the center. We need to do this to exclude these hollow areas in the computation of area, and is shown on the map that these were not affected by the flooding. This time just repeat the process in digitizing using the editor tool, and always check the polygon or feature being edited. As you can see now that the areas I am digitizing are those hollow areas, or in real world, these are the areas not affected by flooding which are located at the center of the flooded areas. Now, look at the data frame. We can see the polygons with the yellow, red, and violet line symbols, wherein yellow for the inland water, red for the flooded areas, and violet for the areas to be clipped. Take note that in this exercise we only aim to digitize or extract some portions of the map. From the Isabella boundary, select the 4 municipalities identified, then proceed to clipping. The selection of few parts of the Isabella boundary was necessary, because as we have said that we only need the portion of the province. We can unmark the raster data to hide it from the data frame, but we can show it if necessary. We will only clip the polygons inside the selected municipalities which shown in blue lines, so all other features outside the blue line or the selected features will not be considered in the clipping. Clipping tool extracts input features that overlay the clip features. This time let us clip the flood inside the target municipalities. The input is flood extent polygon, then the clip feature is the boundary where we selected the municipalities. You may or may not specify the output location, because this is not the final output yet. The newly clipped flood extend polygon will be reflected automatically in the layer and in the data frame, as we can see that the features are all inside the selected municipalities. We can also export the municipalities selected from the Isabella boundary, using the Data Export tab, for us not to confuse with the data on the data frame. Let us name it the target municipalities, but before exporting be sure to select the target municipalities first. Now, remember the not affected areas located at the center of the flooded areas. We need to remove these hollow areas using the Erase tool. In the input features, put the polygon of the flood. Then for the erase features just put the polygon of the areas to remove. You may also specify the output location to organize the outputs. The output will be automatically shown on the data frame after processing. Remove or unmark the old flood shapefile, then retain the newly generated polygon. You can now see the hollow areas, which means the polygons are not totally submerged. Maybe these are areas having a higher elevation in the area. Apply it again with the inland water and the flooded areas, because during the digitizing of inland waters, there were inland waters located at the middle of the flooded areas, so we need to separate it from the flooded areas because they overlap to each other. You can now proceed to map layouting or further processing. Data used in this exercise is provided and attached on the description of the tutorial. To all students enrolled in the subject, put your last name on the comments section as proof of attendance to your laboratory.